Welcome to our Introductory Recording Arts course. In this class, we're going to cover the fundamental terminology used by audio engineers so that you have a solid foundation for learning about mixing and audio engineering in general. By now, you've already looked at the course outline and you have your textbook. So let's go ahead and get into the first chapter, which is entitled, What is Sound? Sound is a vibration or a series of vibrations that move through the air. Anything that creates the vibrations or waves is referred to as the source. According to our textbook, there are 7 characteristics of sound, but we're really just going to be focusing on the first 2 for this lesson. Our first term is amplitude. Amplitude is associated with the height of a sound and is related to volume. A simple way to think of this is just loudness. The greater the amplitude, the greater the sound pressure level. And amplitude is measured in decibels, or dB for short. So here's a quote by 20th century composer John Cage, where he went into a totally silent chamber, expecting not to hear any sounds in that room. And he still heard 2 sounds, his nervous system and his circulatory system. So sounds are always around us, even in quiet environments. For example, in a very quiet library, you'd still get about 30 dB of noise. And that's what this graphic is showing us, is the different rates of dB according to different loudness of different sounds. And of course, when you get into this upper register, that's where you need to protect your hearing. What's our practical application for sound engineers for knowing about amplitude and dB? First thing I would mention is knowing just a little bit about sound treatment. If you're going to create a recording studio, whether it's a home recording studio or a professional recording studio, you need to treat your sound in a couple different ways, soundproofing and also acoustical treatment. So if you watch the virtual tour video for Studio 129, we showed you some before and after pictures where we have special sound treatment in our walls, and we also have acoustic panels on those walls in order to deal with reflections of sound in the room. Our second practical application is talking about measuring levels. So that's something we'll do a lot when we're mixing. And the first example I would mention is when you're setting the gain on a preamp. So if you're recording a signal, the signal could be a microphone or a guitar or a bass plugged in. We'll talk more about gain later, but in general, you need more gain for a quieter source. So if you have a quiet instrument, you need to give the microphone more juice. For example, a loud instrument like a trumpet is going to require less gain than a quiet instrument like a ukulele. We monitor levels on meters when we're mixing audio. These are what the meters look like in Pro Tools software, which is what we use at Studio 129 to mix. Metering colors go from green to yellow to red, and they're measured in negative decibels. Going up to or past 0 dB, which is into the red, is known as clipping. In general, we want to shoot for keeping our levels in the light green to yellow. So that's this area right here. This would be a good recording level, this middle example. Sometimes analog gear can go into the red and it will sound okay, but digital clipping is a big no-no and it will result in an unpleasant, harsh distortion. Our second term is frequency. The amount of cycles per second created by a sound wave is referred to as the frequency. Frequency is measured in hertz, or Hz for short. If you've ever seen this little phrase, A equals 440, if you're a guitar player and you have a tuner on your guitar, that's just referring to our standardized modern tuning where 440 hertz is an A note, and that's how we all kind of end up tuning to the same pitches. And our average human hearing range is from 20 hertz to 20,000 hertz. That's a good range to memorize because that's the area that we work in when we are EQing and mixing audio. We're not making music for dogs, right? So we're not concerned about things that go beyond or above those frequencies. In this graphic, we're looking at the different fundamental frequencies for various instruments. And we're not looking at the overtones or the undertones of those instruments, so it is a little bit more complex than this, but the fundamental notes that you would hit, say, on a violin, going from this low G on up, goes from this note, which corresponds with this pitch. So obviously, higher register instruments are in a higher range of frequencies. So a violin, you're going to mix that differently than you would mix, say, a bass guitar, which is in a lower register. The textbook breaks up frequency into a few different ranges. So the first one is our low or bass frequencies, which is from 20 hertz to 200 hertz. Then we have our mid-range frequencies from 200 on up to 5,000 hertz. And the text takes that on into three different subcategories of mid-range frequencies: the low mids, the mid-mids, and the high mids. Most of the time when we're EQing and we're subtracting sounds that we don't like, we're working in those mid-range frequencies. So that's why we break those up into those broader categories. We also have our high or treble frequencies, which are from 5K all the way up to the top of our hearing range. So our practical application for sound engineers in knowing about frequency, the primary one that I would mention is mixing and EQ. Most mixes include various instruments that emphasize different frequency spectrums. So in this example, we have a drum set, we have an acoustic guitar, we have an electric guitar, and also these two singers, a male and a female singer. So when we're mixing, we would mix all those instruments just a little bit differently from each other. And it's helpful to be aware of these differences in order to make logical mixing decisions, especially when we're shaping the tone with EQ. So, in finishing this module, go ahead and read through Chapter 1, and then you'll take a short quiz related to that chapter, and we'll see you in the next module.